Hello everyone. In this video, we will talk about equivalent fractions. Let's take one small example. If I have this rectangle and I divide it into 4 equal parts and take one part out of it. What is the fraction I have taken? I made 4 equal parts, so the denominator is 4 and I have taken 1, which means the fraction is 1 upon 4. Now what happens if I divide this further horizontally like this? Now what is the fraction? How many equal parts are there? There are these small squares which are equal squares. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 equal parts. So which means the denominator is 8. And how many equal parts I have taken? 1 and 2. I have taken 2 parts. But can you tell me, have I taken extra? It is the same amount I have taken, but it is represented now by fraction 2 upon 8, whereas it was earlier represented by fraction 1 upon 4. Now let's assume that I make few more cuts and I make more equal parts. Okay, so now how many total parts I have? If you see here, 1, 2, 3, 4. So total 16 parts I have. 16. So denominator is 16. And how many I have taken? 1, 2, 3, 4. I have taken 4. But again, if you talk about the amount, total amount, it is same. Which means this fraction must be equal to this fraction and this will be equal to this fraction. Now, such type of fractions are called as equivalent fractions. So in equivalent fractions, you will see the denominators and numerator may be different, but the total value of this fraction is going to be same. And if you have a close look at it, 1 upon 4, if I multiply 4 by 2 and 1 by 2, so if I multiply the denominator by 2 and the numerator by 2, I get 2 upon 8, which is this fraction. And again, if I multiply these by 4 instead of 2, both numerators and denominators, what I get is 4 upon 16. So this tells us that if you multiply both numerator and denominator by the same amount, same number, then the new fraction which you get is going to be equal value to the original fraction, and it will be called as equivalent fraction. We'll see one more way. Let's say I have 18 marbles, and out of these 18 marbles, 6 marbles I give to my friend. So how many marbles I have given in terms of fraction? I have total 18 marbles. So my denominator is 18. And I have given 6. So my numerator is 6. So the fraction which I have given is 6 upon 18. Now let's assume that I make groups of 2. I don't count the marbles individually, but I count them as groups of 2. So if you see how many groups of 2 I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 groups. Total groups are 9. So my denominator is going to be 9. And how many groups of 2 I have given to my friend? 1, 2, 3. I have given 3 upon 9. But if you see again, the value, the total number of marbles which I have given to my friend are same. They have not changed. I've just made the group of 2 and I say that 3 groups I have given, but the marbles are exactly same. Now let's say that I make group of 3. Now let's see how many groups of 3 I have. 1, 2, 3, 4, 5, 6. I have 6 groups of 3, which means my denominator is 6. Total groups 6. Out of which, how many I have given to my friend? 1, 2. I have only given 2. But again, if we see the value of or the total number of marbles which I have given are same, which means these fractions are same in value. So they are equal. So again, they are going to be equivalent fraction. So let's again see one more thing. If I have 6 upon 18, I divide both numerator and denominator by 2. What do I get? I get 3 upon 9, which is same thing what we have here. Or if I have 6 upon 18 and I divide both of them by 3, then I get 2 upon 6. And that's what I got here. So we can say that we can also get equivalent fraction by dividing both numerator and denominator by the same number. So what we have said till now is equivalent fractions can be obtained by multiplying or dividing both numerator and denominator by the same number. So what is important here? Dividing or multiplying both numerator by equal number. Let's talk about one more concept here. Let's talk about lowest form. So if I have a fraction, let's take same fraction, let's take 6 upon 14. Now if I look at these fractions, I see that there is a common factor. So let me write their factors. So 6 can be written as 3 into 2. I want to write the prime factors. And 14 can be written as 7 into 2. So once I have the prime factors, I will cancel out the common factors, because we know that if we divide by the same number, we get equivalent fraction. The value of the fraction does not change. So I will cancel out the common factors. And that gives me an equivalent fraction of 6 upon 14 as 3 upon 7. Now, are there any common factors? These are prime numbers, so there are no common factors between them. So when we have a fraction where the numerator and denominator do not have any common factor, we call them the lowest form of fraction. The only common factor between them is 1, and then it is called a lowest form of the fraction. One interesting pattern we will observe in the equivalent fractions. Now we know these two are equivalent fraction because 3 into 4 is 12, 5 into 4 is 20. So if I multiply this by 4, both numerator and denominator, then I get 12 upon 20. So these are equivalent fraction. Now let's do one thing. Let's do cross multiplication. So numerator of this fraction with the denominator of this fraction. So 3 into 20. And let's multiply 5 and 12. Denominator of this fraction and numerator of this fraction. What do we get? Here we get 60, here we get 60. They are equal. So In equivalent fractions, the product of numerator of one fraction and denominator of other fraction and denominator of first fraction and numerator of second fraction is same. This pattern can be used to easily find the equivalent fractions. We will see this when we solve some practice sums. I am sure you have liked the video. Hit the like button and leave your views in the comments section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the QTube app at the link provided in the video description. Till we meet again, goodbye.